Hello, everybody. In the last screencast, we looked at how to identify if a reaction was an oxidation reduction reaction. And now we want to take a closer look at both halves of that concept, that there is an oxidation and there is a reduction. We want to look and see how many electrons are being gained and lost by each half of the reaction. So this is writing oxidation reduction half reactions and making sure that they're balanced. So in order to do that, the first thing that you need to do is go through and write the charges for all of the elements in the compound. Now, one thing that's kind of nice is that if you have a nitrate on both sides and the polyatomic ion does not change at all, then what you can do is you can ignore it because you know that those charges in the elements that are involved in the polyatomic ion must not have changed. So when you go through and you look at the copper and the silver, you can determine that the copper is a 0 charge, the silver is a +1 charge. I did do the nitrogen and the oxygen in the nitrate just to show you that those charges did stay the same, and you can ignore them. The silver, again, because it's all by itself, hasn't gained or lost electrons to anybody, is 0, and the copper is +2, based on the fact that nitrate's -1 and there was 2 of them, the copper's +2. All right, so once you know the charges for all of them, now we want to pull out and identify what's being oxidized and what's being reduced. So we've got two things that are changing. Our copper is going to copper +2, and our silver is going from +1 to 0. So because the copper is going up in charge, we say that it is being oxidized, and the silver's charge is going down. So the charge is being reduced. The silver +1 is being reduced. And I wrote those there. And now I wrote them without any electrons right now. All I'm doing is identifying the oxidation and reduction and showing how they change. So the copper 0 goes to the copper +2, and the silver +1 goes to silver 0. Charge goes down, reduction, charge goes up, oxidation. And those are the two halves of this redox process. Now we want to put the electrons in. So now we've got to figure out how many electrons are needed in each one of these. But first we're going to balance it for mass. So we want to make sure that we have the correct number of copper atoms and silver atoms on both sides. Here I have 1 copper, and here 1 silver and 1 silver. So right now I am balanced for mass because I have the same number of each atom on both sides. It's not always that way, but this time it's nice and easy. Once we're balanced for mass, now we have to balance for charge. Now, if I'm going from 0 to +2, it must mean that I'm losing electrons. In fact, I'm losing 2 electrons from the valence shell, and that brings me from the 0 atom to the copper +2 ion. But for the silver, I'm going from the +1 ion to the atom. So now I have to gain an electron. Now I have two balanced half reactions. Here is my oxidation half reaction. Here's my reduction half reaction. Now, the other thing that you should notice is not only am I balanced for mass, but I'm balanced for charge. The reason being, if I add up this side, I do get a 0 charge, and on this side, I get a 0 charge also. So I have an equal charge on both sides. It's not always 0, but it should be equal. Here in both of these, you do happen to have 0 on both sides, and I'm balanced for mass and charge because of that. Now, at the bottom here, I just wanted you to see that something is giving off the electrons and something is taking in. In a redox reaction, you can't have one without the other. That's what makes it a redox reaction, and that's why we have to look at both halves. Ultimately, what's going to happen is you're going to see I could make a battery out of this copper and silver, and the electrons would flow from the oxidation to the reduction, and that would be my battery. Now, identifying and balancing half reactions in something like this can sometimes prove to be a little bit more difficult. So first, we want to identify the charges. Now, in order to identify the charges here, if an element is by itself, it's 0. If it's in a compound, we have to figure it out. Hydrogen's +1, oxygen is -2. Then you pull out your half reactions. Here, you usually don't include the subscripts on the compounds. Only if it's a diatomic do we include the subscript. So we would get H2 here, because it is diatomic with a charge of 0, going to H +1. Notice I left this 2 out. The reduction is very similar. I go from 0 to a -2 charge. All right, once you get the oxidation and the reduction, the charge goes down, the charge is reduced. That's usually the easier one to identify first. And then the oxidation, the charge goes up. Now we need to balance for mass. For the H2, notice that I had to put a 2 in front of this hydrogen in order to balance it for mass. The O2, I also needed to balance with a 2 in front. Okay, now that it's balanced for mass, now we balance for charge. 2 electrons are given off here because each hydrogen goes from 0 to +1, but I have 2 hydrogens that are actually doing the change. So not 1 electron, but 2 electrons are being lost when that occurs. For the oxygen, similarly, I go from oxygen to -2. Each oxygen needs to gain 2 electrons, but there are 2 oxygens that are changing. So each oxygen is going to need its own 2 electrons, which means there's a total of 4 electrons being gained. So 2 electrons lost here, 4 electrons gained by the other. What's the oxidizing agent in the problem above? Remember, anytime you see oxidizing agent, cross it out. Write what is being reduced, and that will help you get your answer. The answer is the O2. O2 goes from 0 to -2, so it is reduced, but is considered the oxidizing agent. So determine the balanced half reactions for each of the examples below and label the oxidizing and reducing agents. Why don't you pause, try these, and then turn it back on and get your answers. Okay, so your copper went from +2 to 0. It gains 2 electrons. That's being reduced. The aluminum goes from aluminum to +3, being oxidized, and that's losing 3 electrons. Balanced for mass, 1 copper here, 1 copper on this side, 1 aluminum on the reactant, 1 aluminum on the product. There's your oxidation and reduction. For the bottom one, your lithium goes from 0 to +1 by losing 1 electron. Remember that this is your oxidation. And anytime you have an oxidation, Leo is loss of electrons. Here, you're going to go from +3 to 0. 3 electrons need to be gained because this is the reduction. This is a gain of electrons is reduction. Leo Ger, if you want to go back to that. And that's it. Thanks for listening. Have a good night, and I'll see you tomorrow. Oh, I forgot the oxidizing agent, reducing agent. There you go. Have a good night.